Hello students, so today I will be talking about the ICSE Robotics and Artificial Intelligence grade 9 course, and in particular I am going to talk about the building blocks of robots, which is there in the part 1 of your syllabus for robotics, right. So, let us start. You see, the building blocks of robot can be divided as three fundamental integrated components. So, basically we have got three components. What are they? The first is the mechanical component, okay. Next is an electronic component, and after that we have got computational blocks. And you see, each block has a specific role, and we will illustrate this through examples. So, let us first talk about the mechanical block. Now, this block forms the physical structure and enables movement and interaction. Now, in the childhood days, whenever we think of robot, the thing which comes to our mind is the physical structure itself, and in our childhood days we used to think about only the mechanical block as being the part of a robot. But now we know that it has got in fact two more components. Good. So, now what the mechanical block includes? This includes, you see, parts such as frames, joints, actuators, which are motors, hydraulic or pneumatic cylinders, then wheels, legs, arms, and end effectors, that is the hand, something like that, grippers and tools. Now, what is the working principle? Actuators, actually they convert energy, which is either electrical, hydraulic or pneumatic, into mechanical action, and joints and linkages transfer and guide this motion. So, you see, the mechanical block physically executes tasks like gripping, moving and walking. Now, let us see an example. Now, in a robotic arm, the servo motor acts as actuators controlling the joints rotation. Okay. So, what is next? You see, the motors receive control signals and move the joints accordingly, and the mechanical structure positions the arm to carry out tasks like picking or placing objects. But remember, there is something called feedback. You see, the feedback from position sensors, it is also there. They will basically ensure the accuracy of this work, okay, by comparing the actual position to the desired position, and if correction is required for any error, it will be done. So, you see, we have got data analysis or data science being working over here. So, you understand this thing. So, the feedback from position sensors is the data which will be again analyzed by the brain of the robot to do corrections if necessary. Good. So, what is the next block? Well, the next block is basically the electronic block. Now, this block includes power sources, sensors, actuators, drives and circuitry that interface between the computational commands and mechanical actions. So, basically what it does, it gathers information, data about the robot's environment and also the status of the robot, internal status, through the sensors and powers the mechanical components to act accordingly. So, what is the working principle? Basically, sensors, which are either cameras, distance sensors, force sensors, we have also talked about temperature sensor, pressure sensors and all that. They detect the physical parameters and send the electronic signals to the computational block, and after that you see the electronic circuits amplify and convert signals to drive actuators and power the system. You understand this thing? So, let us look at an example to further clarify. Well, sensors such as cameras, proximity sensors and force sensors, they detect the environment and the position of the robot's parts. Now, these sensors send data electronically to the computational block. In the meanwhile, you see actuators like servo motors receive pulse width modulated signals. It is a type of electronic signal. You will learn in class 11 or 12, I guess, in physics. Now, they receive this pulse width modulated signals from the electronic circuits to move to the desired position. Okay. Next comes the computational block. Now, this is basically the robot's brain, right, consisting of microcontrollers, embedded computers or processors that run algorithms for decision making, control and coordination. So, the working principle is that this control block processes sensor data, runs control and planning algorithms, thereby making decisions and sends the control signals through the electronics block to the actuators who actually do the performance, right, do the work. Now, it closes the feedback loop by continuously comparing sensor input to the desired action. This I have just talked about in the last section, and thereby making corrections in real time. Okay. Now, to further illustrate, let us look at an example of a microcontroller which is inside a robot. Now, what it does, it processes input from sensors, then executes motion planning algorithms, okay, and sends the pulse width modulated signals to servo motors to position the robotic arm. Now, the thing is that it continuously monitors errors between the intended task and the actual performance. Just think of it in your classroom when you go to school. Suppose the teacher asks you to explain something and you do a mistake, the teacher will immediately correct yourself. So, see, this is a very nice example of artificial intelligence working here. So, thereby adjusting commands dynamically, that means real time, to achieve the required precision. So, if I have to overall think of in a nutshell, then the computational block basically plans and makes decisions based on sensor input, and these decisions become the electrical signals in the electronic block. Afterwards, you say the mechanical block physically executes the movement or task based on these signals. So, the sensors provide feedback to the computational block to close the loop and ensure accuracy. Now, before I end today's class, let us just have a brief overview of the various working principles. So, the mechanical block, what is the main component? Joints, actuators, frames, grippers. Working principle: convert energy to mechanical motion. Examples we have talked about, right? Robotic arm joints, grippers, which are controlled by servo motors. After that, we have the electronics block. Here, the components are sensors, circuits, power supply, and here basically this block converts sensor data to electrical signals and powers actuators. And we have talked about sensors detecting environment, the pulse width modulated signals driving motors, and finally we have the computational block, which includes microcontrollers, embedded processors and software. Basically, they process data, plan actions and send commands. Okay. So, who sends commands? Well, microcontroller, some example, right, which controls the robotic arm motion. Modular robotic blocks, they communicate. Now, you see, these blocks work in tight integration, forming a complete robotic system. For instance, in modular soft robots, the mechanical flexible joints combined with electrical and computational blocks, they enable shape transformation and locomotion. Similarly, what about self-transforming modular blocks? They contain embedded flywheels, magnets and microcontrollers to jump, spin and communicate autonomously. So, basically my dear students, understanding these building blocks provide with a framework for designing, analyzing and innovative robotic systems, from industrial arms to versatile modular robots.